Hi, I'm Mike Parsons, Director of the Vester Field Station at Florida Gulf Coast University. Here we are out on the water at the field station off of Bonita Beach Road. And today I'm going to talk to you about our Rink to Reef program. Our Rink to Reef program was actually started by our FGCU hockey team, where they were trying to find ways to repurpose broken hockey sticks instead of simply throwing them away in the landfill. So they came up with this oyster habitat idea, which we now call Rink to Reef. The idea is that these habitats will recruit oysters, and the oysters will settle on them, and we can get tens or hundreds of oysters that settle on these units. Each adult oyster can filter tens of liters of water, so if you have hundreds of oysters on each unit, we're talking about thousands of liters of water that can be filtered every single day. The oysters filter out algae and particles from the water. That helps to clean the water. It helps to make the water clearer, which is good for seagrass beds and is good for us who want to look at nice clean water. So it's a good program all around. Oyster reefs also bring in things like barnacles and larval fishes and other small fishes, as well as shrimps and crabs. So these Rink to Reef units create basically a little ecosystem for other organisms as well. They give our students great opportunities to do hands-on science, to interact with the community. The community gets an opportunity to put these Rink to Reef habitats out underneath their docks, which helps to clean up the water and create oyster habitat. So it's a win-win all around, where we can do our part to try to clean our waters.
First of all, I would like to thank the Sanibel-Captiva Shell Club for their interest and generous support for our research at the water school in Florida Gulf Coast University. Their support means a lot to us. This funding was really helpful in supporting undergraduate students during the hard time created by COVID-19 pandemic, and in some cases, it was the only source of income for some of the students. The support from Shell Club, along with other funding sources, have been used to study radium and nutrients in various water samples from the Southwest Florida region. Radium is a naturally occurring radioactive metal, and it is found in different forms in nature. We call these different forms of radium as radium isotopes. The combination of radium isotopes is unique for a specific source of water, meaning the groundwater has different types and amounts of radium isotopes compared to river and seawater. As different water sources have different signatures of these radium isotopes, they have been used as a tracer for source of water and also to track associated nutrients in a specific body of water. Tracers can help us track things like nutrients or pollutants back to their source. It is like retracing the steps from a crime scene. It helps us determine where the water and nutrients are coming from. This is why our main aim of this study is to use radium as a tracer for nutrients in various Southwest Florida water bodies, because as we all know that nutrients are major environmental problem in this area. Despite COVID-19 pandemic directly affecting our teaching and research activities, we were able to go out and collect water samples from different locations for radium and nutrients analysis. While we are still working on some of the sample analysis, once we have all the results ready, it will be very helpful for us to determine potential source of nutrients in this region. The funding from the Shell Club was used to purchase supplies and to partially support 4 students working in my lab. Two of them recently graduated, and other 2 are currently working on this project. The students currently working on this project, James and Jack, are very excited to share their work to the Shell Club. Again, I would like to thank the Shell Club for their interest and support. And now let's see some of the work that we have been doing for this project.
This is the pump system we use to help collect the radium samples, and I'll be momentarily dipping this in the water to help collect the water we need to collect the radium. And then, there we go, all right. So, what we do is, as that water's flowing up this pipe, it flows into this filter over here, just like your household filter. This one gets the majority of the gunk out of the water before we put it in the super expensive instrument.
As this gets filtered through these manganese fibers over here, this is actually what gets put in the instrument, so we want as little contamination as possible. We want just straight radium.
And we use manganese fibers because they act like a magnet to attract radium, so it collects any radium that was present in the water.
What we do is we take this, after this is filled up, screw it on tight, and then we hang it over the side. Hang it over the side anywhere really, doesn't matter, as long as that gravity can pull the water down through these fibers. And as this water flows past these fibers, the manganese fibers actually, as he was saying, pull that radium in real tight and filter it out of the water.
Right now we've taken our manganese fiber from the pump system, it's all dried out. I'm going to stick it in this tube and attach it to the radix system.
So the way the radix works is after this gets all hooked up, we turn on a helium gas tank. And that helium gas is a carrier gas. It carries the radium all throughout this system. We got our detectors at the top on the left and the right, and they detect two of the isotopes of radium, 219 and 220. We leave this for about 4 hours, just circulating constantly, detects every time it breaks down, and then that's what helps give us one ratio that we use to track these water sources. So once we are done running these fibers on the other radix machine, we actually bring them down here to work with the germanium detector, and I pass them off to Zach.
And then we take the manganese fiber, we put it in this crucible here, we place it in hot oven. And then once it's finished, we take it out of the hot oven. This is what the manganese fiber looks like when it's out of the oven. And I take the manganese fiber and I grind it using this. It takes several attempts, and once it's done, this is the final product of what it looks like after I'm done grinding, and now it's ready to be put in the germanium detector.
So we took that initially large volume of fibers and we ground them all the way down to this nice powder, and we put them in here, the germanium detector. We close this giant lead shield, and we actually let this run from anywhere from 1 to 4 days. The radioactivity is so low in it that we have to let it run for that long amount of time. It's no danger to us or anyone else. But using the numbers that we get from this, we can actually track the water sources. As Puspa was talking about earlier, you have different isotopes of radium, and we can look at those different isotopes using this. And as we find where they're coming from, we can look at other sources of water and say, hey, our ratio matches that ratio, so this water must have come from there. And in this water are nutrients and toxins and a slew of other things that we're looking at.
I'm Greg Tolley, Executive Director of the Water School at Florida Gulf Coast University. You know, when I think of water, I think of clean drinking water for human health and well-being. I think of water for economic development and social development and prosperity. I think of water for healthy ecosystems that bring people to Southwest Florida in the first place. Our lovely beaches, our mangrove areas, our seagrasses, fishing, birding. These are all things that are important for us here in Southwest Florida. But water isn't always our friend. Floods, droughts, sea level rise, hurricanes, these all impact our areas in negative ways as well. So it's important to think of all these connections of water as part of a system, part of a larger system. And when we get the water wrong, the entire system can collapse. So what the Water School is trying to do is make sure that we get the water right. And we do this by applying a more holistic approach to looking at our water problems. We have faculty from over 4 different colleges and 16 different departments in the Water School, colleges including engineering, business, health and human services, and the College of Arts and Sciences. And we're trying to come up with solutions that are more sustainable, solutions that look far into the future to make sure that there aren't any unintended consequences, solutions that look beyond local boundaries to make sure that what we do here in Southwest Florida isn't impacting our neighbors to the north or the south or the east. Our students here at Florida Gulf Coast University are looking at sea level rise, climate change, how to restore important ecosystems, including the Florida Everglades and other wetland areas, for example, the importance of shorebirds in terms of our local ecosystems and how our development and our behavior can actually impact those shorebirds. So when I think of water as the economy of Southwest Florida, as the driver of Southwest Florida. And so when you give to Florida Gulf Coast University, you're helping to fuel that. We want to thank you for your support of Florida Gulf Coast University. I always say that our number one responsibility is to our students, but our number two responsibility is to our community. We feel very, very embedded in the community and a part of you, and we want you to feel that the water school is your water school as well.